Right, good morning, everybody. My name is Ben and I'm CEO of the Silverstone Technology Cluster. Welcome to another webinar. We have a very interesting session for you today on collaborative smart automation. I'll hand over to Niels in a moment for what should be a very fascinating session. Just wanted to remind everybody that obviously when you're on the call here, we're recording this session and we'll share the recording and the slides with you after the event, as well as the contact details for Carol and Niels as well, so you can follow up if you want to. Niels will run through his presentation and will invite sort of questions afterwards. So by all means, note your questions down for afterwards, and then we'll ask them. As you all know, this is all sort of part of a series, so we have more webinars coming up, and I would invite you to have a look at our website for forthcoming events. I kind of also wanted to highlight we have a future mobility event going on next week on the 10th of November, which will be quite interesting. So if you wanted to join that, please have a look at the website and book on for that. Again, that will be online, of course. And then towards the end of the month, on the 26th of November, we have our annual conference, which should be a fascinating event as well. So again, please have a look at the website and sign up for that. Obviously, all of these webinars and a lot of our event videos are all available on YouTube as well. So if you wanted to catch up, please visit YouTube and our channel there. I'm sure if you search Silverstone Technology Cluster on YouTube, you'll find us and obviously can catch up there. Right, so that's kind of the admin out of the way. So I'll now hand over to Niels to start the presentation. Thank you.
Good morning, everyone. Niels Lohse from Loughborough University. Thank you very much for the time to kind of just give a short overview of smart collaborative robotics. I'm going to share my screen. Give my computer a second to. So hopefully that should be now, or you should be seeing my screen kind of appearing now.
Yeah, perfect.
So great. So just a kind of brief outline of the presentation. So I'll start with a short introduction just to kind of give a little bit of background of, kind of myself, who I work for, and what we do. And then I thought it'd be a good, kind of good chance to talk a little bit about kind of smart robots, what they do, what the challenges are. And finally, I want to talk about kind of some opportunities for kind of research collaboration in this area, to kind of highlight some of the initiatives that we're kind of putting together and how you can actually get involved with those. So as an introduction, just, I work for Loughborough University. We're one of the kind of top 10 research-led universities in the UK. I believe we're consistently ranked first for student experience. So students do like to come to Loughborough and enjoy our campuses. We've got two facilities, one obviously in Loughborough, and we also have a campus in London, which is predominantly looking at postgraduate teaching, which is actually looking at the Queen Elizabeth Park. We've been quite successful over the years to kind of get involved with various types of engineering and, of course, sports-related activities and a whole range of other things, which is kind of reflected in us having won 7 Queen's Anniversary prizes, the latest of which was in high-value manufacturing, which is quite, kind of related, of course, to the things that I do. So most of the automation we do related to manufacturing. Couple of words about the Intelligent Automation Center, which I have the pleasure of leading here in Loughborough. What we do is we focus on automation that is currently difficult to achieve. So these are typically things that are considered to be squarely within the kind of manual domain, or things that require quite complex systems and processes. So what we do is we're looking at understanding how people interact with things, how we carry out processes at the moment, and then looking at first principles by which we can actually then improve those processes. Increasingly, those tend to be kind of collaborative in nature, so kind of supporting and enabling people, kind of maximizing their skills, but also looking at kind of novel systems by which we can actually create new capabilities that are not kind of limited by just the kind of automation that is currently available. So most of you that have actually dealt with automation will probably be aware that automation systems are typically kind of designed to kind of do repetitive processes, which are essentially kind of dead reckoning, so blind processes. So where a robot is actually set up to carry out a program and then repeat that program quite successfully, again and again, provided that the conditions don't change. However, many processes that we encounter in the real world, of course, not in this are variable in nature and actually don't follow that kind of principle. So this slide just kind of shows a couple of examples, some of them quite extreme in a sense that you may be familiar with a kind of a process called panel beating. So the idea of that is that you have a sheet of metal and you use a mallet, and a very skilled person can actually then form that sheet metal into a kind of quite complex three-dimensional shape. Typically, I've been told, I haven't actually tried myself to follow that direction, but it takes about 5 to 10 years to become quite proficient at that skill. So what we're looking at is then those types of things and say, why is that? What do people do? And it typically is kind of very complex hand-eye coordination activities where you rely on sensors and feel, touch, and so forth to actually understand the processes. And so we're investigating those things and then looking at sensing solutions. We're looking at kind of intelligent algorithms, if you like, that actually embed those types of behaviors, but also ultimately looking at the dynamics of the system as a whole. So here's another image actually where we're looking at kind of soft gripper solutions, for instance. So if, for instance, you want to pick up an object of variable size, then that object actually, if you have a hard tool, that tool actually may actually damage that object or needs to be physically changed and adapted in your design process as you go along. However, if you have a kind of a soft tool, then it can actually form around that object and actually then adapt to the shape of that object. What is the challenge with this is that then you also lose kind of the kind of knowledge of where that object is, as you're moving it through space. So what we're interested in is kind of looking at this kind of combinations where you take advantage of some of those kind of mechanical and soft structures and combine them with sensing solutions to actually then enable you to kind of get your kind of precision and so forth. And that's just a couple of examples out of the range of things that we do. What I want to talk to you about today is kind of, the kind of challenge for industrial automation. So most of you might be aware, I mean, there's been various reports over the years to kind of look into kind of automation, particularly in the UK. And it's a kind of a fairly wide-known fact, I think, that the UK is kind of a little bit behind compared to other countries. So it's currently ranked, as you can see, 22nd worldwide for robot density. So that's the kind of number of robots installed per kind of worker or 1,000 workers working in kind of manufacturing context. So the question is ultimately, why is that? Why are we not taking advantage of robotics more? And also, if you look at places like China, for instance, which are of course traditionally kind of thought of as low labor cost economies, the number of robotic installations is actually going up and actually exceeding now the installations in the UK. And actually, in terms of unit cells, actually they're leading the world in terms of the robots actually being deployed on a year-by-year basis by quite a margin. So there's some questions of why is that? And of course, this is what we're interested in is why are the these barriers there? Why are people not adopting it? And of course, one of the things that comes to mind is what is the high initial investment cost, if you like. So the kind of financial models that are actually going with that. And of course also the kind of level of certainty that you have to have. So if you're in an industry that doesn't work with high volumes within a stable market, then it often becomes difficult to justify deploying automation. So there the question is, how do we make automation more adaptive to actually address those types of things? It's quite complex, and maybe there is a kind of capability and a skills barrier as well. So how do we actually hire people that actually have the necessary skills or lower the requirements of skills to actually deploy those types of systems and actually take advantage of those? So there's various reports actually looking into those types of things. Now, where we're going with this is that there's a kind of an increased kind of notion that we're looking into kind of collaborative robots or systems that actually more naturally, if you like, integrate and work alongside people, or actually kind of benefit from people doing the kind of installation phase to set them up very quickly with little tooling, engineering processes around it. So the things that typically take a long time. So if you're working in automotive industry or something like this, the kind of baseline figure is roughly that it takes about a month to kind of configure a robot for 1 minute of work. That's quite an initial investment actually required, to kind of do a repetitive process or a process that takes 1 minute. Now, so there are lots of robots now actually emerging that are designed for people to interact with in a more natural way by, for instance, guiding them through a process, as you can see here on various pictures and so forth, but also kind of minimizing the barriers between them by reducing the kind of need for kind of safety systems and fenced off areas, which actually reduces their footprint and so forth. So again, hopefully, you're roughly familiar with that. Projections at the moment kind of indicate that by 2030, this will be a market that is somewhere in the kind of 11 billion. At the moment, the market is around as you can see here, is about 711 million. Last year is about 1 billion now, if you consider all the kind of implications or all the kind of fringe processes around that. What are we trying to do with this? And again, I'm just borrowing slides from other people here that are actually working in this field. But ultimately, what it's about is kind of trying to see if we can push automation from the area of low number of variety, high productivity, minimal flexibility and large lot sizes into the space that is traditionally for manual labor, where you have high flexibility, small production volumes, small lot sizes, and high agility. And building something that actually sits somewhere in the middle, or at least pushing this boundary further down. And here the challenge is, of course, is how do I make robots smarter, if you like, so in the sense of allowing them to recognize and reason about the environment in which they operate, give them capabilities to actually do more kind of hand-eye coordination type of things, dexterous manipulation capabilities and things like that. On the other side is, can we actually get better synergies between what people do and what the automation is actually doing, so that we actually kind of get a better balance and we remove, as I said before, this kind of traditional barriers where something is either automatic or manual. And even more so, how do we actually deal with things like de-skilling of the workforce, where certain processes that are easy to do with a robotics system actually then push people to do kind of quite demeaning tasks, actually like bin picking and things like that, which are actually not particularly good for, I think, their self-esteem, let alone actually their kind of salary. So what are the kind of expected benefits? You can see here lots of numbers. People are kind of looking at this. I mean, this is a huge industry. There's lots of potential benefits in terms of the industry value, cost saving potentials, other things like job satisfaction. People actually working with collaborative systems actually are tending to kind of feel more involved in that process, and again feel that their skills are being appreciated rather than actually just kind of serving machines, and other benefits like kind of reduced CO2 emissions and so forth. Quite an important element as well, in my opinion, is actually one of the biggest issues in industrial jobs, depending on the kind of where you work, is kind of musculoskeletal disorders. So there are many cases. It's one of the biggest kind of cost factors and health factors actually in the industry. So again, creating systems that allow people to more naturally interact, first of all, creates direct health benefits, but also the kind of secondary benefits in the sense that people actually then use those systems rather than actually circumnavigating them. So there are many cases that one can point to say that lift support systems, for instance, have been provided, but actually people don't actually engage with them because they don't actually follow the way that they naturally work with them, and therefore then actually don't really deliver the benefits. What's also quite interesting is that there's a kind of, it seems to be that there's quite a lot of investment in the UK actually in startup companies in the robotics field. So that's quite encouraging actually, where we actually seeing that traditionally, I'm in kind of manufacturing automation. Most of the suppliers will be outside the UK, pretty much all of them. Yeah, when it comes to technology suppliers, that picture is slowly changing, and I'll be honest, I'm quite keen to see that changing more. So actually seeing a kind of a better landscape actually for people to invest and actually build solutions here would be really interesting. Okay, so that's kind of a little bit of background. So where we come from, what the opportunities are, what the challenges are. And some of you may be aware that there's various challenges from the Industrial Strategy Challenge Fund that are actually kind of supporting businesses to kind of develop research and innovation, but also kind of providing some opportunities for universities to engage with businesses to actually do those things. One of those initiatives is the Manufacturing Made Smarter one. And one of those activities within the Manufacturing Made Smarter is actually looking at creating some research centers that will actually address some of the kind of fundamental barriers for those smarter manufacturing and actually create, if you like, the kind of new solutions, new ideas that we need to actually put into the pipeline for new technologies to emerge in the next years to solve the kind of future problems. Where do we sit with this? So the kind of the budget that is being provided for this, so this is the kind of opportunity, if you like, for engagement, is that EPSRC, which is the Engineering, Physical Sciences and Research Council, has set aside 20 million as part of this initiative to fund 4 to 5 centers. So the budget is therefore around 4 million. The duration is about 42 months, and it needs to have quite a strong industrial contribution. Of up to 25% of the EPSRC contribution, so that's about £1 million. Yeah, the way this funding is structured is that there will be about 50% of that funding that goes to each center is going to look at underpinning research. So kind of looking at what are the kind of the barriers that prevent automation to kind of be more prevalent within businesses, and look at what we can do about it. So looking at underlying research activity to say, well, if we advance that technology, what is the next thing that we can actually provide that actually provides better capability, better training, and so forth. There is another roughly 50% to look at responding to emerging industry needs. So the way we look at this is that this should be something where we're looking at cross-sectorial, cross-disciplinary case studies, and then actually doing some demonstration activities that actually show how we can actually solve those types of manufacturing and related challenges using smart industrial automation. And then thirdly, there's an element of networking, which is looking at kind of community building and making sure that we actually connect all the kind of key actors within the kind of research and development space around robotics together, again, to kind of create a more vibrant ecosystem that, again, will benefit everyone. So the idea is really to kind of grow the pie for everyone to say in automation, we want to have a kind of bigger opportunity because we are a little bit behind, and how can we actually increase that? And then everyone benefits out of that, either directly as a user or a technology provider or system integrator. So I'll talk about the innovation themes in a minute. So there are kind of different types of topic areas that are covered. But I just wanted to kind of give an overview of the team that we put together for this particular center. So as an academic team, we have ourselves, Loughborough, leading it. That's why I'm talking to you today. We are coming in from the kind of background, as I kind of highlighted, of this kind of smart automation systems, looking at digitization topics. So how do we actually collect more information, richer information about the workspace, but also creating novel mechatronic architectures to kind of address the next automation challenges. We have Frankfurt University, who are looking at kind of mainly aerospace type of problems, but also come with a very strong track record in safety, kind of the social elements of robotics, trust, and how that actually relates to regulation, because that's obviously quite an important area in this field. So we need to make sure that whatever solutions we're designing also meets with current and or future regulations as appropriate to make sure it's safe. The University of Strathclyde is looking at a kind of integration with the food so agri-food, construction and space automation side, and they're coming from a kind of more kind of digital integration perspective. Bristol is coming in as a kind of Bristol Robotics lab. This is kind of the more kind of scientific robotics side, so the kind of theoretical robotics, and they are kind of looking at kind of soft robotic structures, novel systems, and validation and trust. So they're just kind of being awarded a big grant actually that is looking at autonomous systems and trust. So how do we actually trust those types of systems and work with them? And Warwick is looking after some of the automotive side and looking after the more modeling side, so variation-based modeling, to say, well, how do we actually map the variation that we see in our processes to the level of kind of dexterity that we want within our automation systems. In terms of position, the way we look at this is that when you look at innovation, we want innovation to happen here at the very end of the technology readiness pipeline. And in order for that to happen, we feel that a lot of new solutions need to be generated and a lot of new ideas, basic ideas, need to be generated, many of which will turn out to be probably not quite as feasible as we thought. And so we need to actually have a mechanism by which we can narrow down that funnel, if you like, of ideas quite quickly. And where we see this center being placed is at the kind of saying, well, we generate lots of ideas in the university, and then this center will kind of come in to work at the interface between the kind of catapult centers and research and technology organizations that have already been established to kind of work on the industrialization topics, for us to work on the kind of concept development and proof of concept. So we actually see that this center will be kind of putting in the new concepts on the shelf of the catapults and innovation organizations to pick up and see how we can actually take those forward. And therefore, we've reached out to many of those innovation partners. As you can see, we have quite a big list of people involved already, covering most of the high-value manufacturing catapults and related RTOs, and then also bringing in some in construction and agri-food that actually are covering this. The notion behind this is that we want to kind of really kind of provide a central contact point for smart automation across those different sectors. So be that, kind of composites, be that kind of advanced manufacturing, be that construction automation. There are many common challenges that can actually be addressed in this area. And we've already have quite a lot of support. So you'll see there's, quite a lot of end users that already indicated that they want to be involved in this center to kind of run feasibility studies, kind of contribute to kind of the guiding and steering of this, and also providing and allowing us to kind of collate the kind of cross-sectorial challenges that then actually allow us to kind of work on the most relevant research to overcome those barriers. Also, very importantly for us, as I said before, we want to work very closely with technology providers and system integrators, because unless we reach out to the people that actually provide and market those solutions and then integrate those solutions, whatever we do at the beginning of the pipeline will ultimately not really find its way into practical use. So of course there's a balance here, and you can see that some natural competitors like KUKA, FANUC, and ABB are actually a part of this, and they kind of understand that at the early part of the research and the development, we need to have a kind of a representative overview of the technology area, rather than actually working on specific solutions that they can then think of and say, how do we actually translate that into something that can be packaged up as a product or service that we can actually then market, which is down to everyone's individual creativity and drive and strategy. Okay, so what are we actually aiming for? What we want is we want to kind of eliminate, as I kind of indicated before, this kind of underpinning barriers for a kind of wider spread adoption of automation. So it's really kind of looking into what can we do to enable companies to more successfully and find it easier to adopt automation within this space. And that's why kind of we said, okay, one of the elements, of course, implied also by the call, is we need to look into smartness. What does that mean? What we think it means, or what we interpret this to mean, is that we have more sensing, and also cost-effective sensing. So how do we actually provide better data, higher quality data, and then link that to decision-making processes, autonomy in decision-making processes, and also better acting capability. And of course, all of those has to be within a kind of a cost context, which is also, of course, quite challenging. And what that will lead to, we think, is better and increased adaptivity, simple automation, where we say, well, actually, if we reduce the cost, so this is, of course, one of the challenges where we say we increase the complexity, we add more sensors, we have more reasoning, we have better acting capability, but how do I make it simpler? The way we look at this is actually by reducing all the kind of hard coding and skill requirements that people have around automation, by taking advantage of multiplying effects where you have multiple cheap sensors actually replacing monolithic, quite expensive systems, and creating similar type of capability. We're looking at improved collaboration. So actually, again, this kind of synergy effect between what people are good at, the kind of creativity, problem solving, where you say, if I'm setting up a process, typically people are really good at figuring out how to do that particular process when they do it for the first time. Robotic systems are not. They don't have any kind of knowledge of the area, don't have any understanding. But if I translate that knowledge and say, let's get a person to actually solve that, get a robot to watch what that person is doing, and then actually learn from observation. And then at some point, when that person gets kind of saying, well, I found out an optimal way of doing that, the robotic system might continue, right? And then the person moves on to the next cell and actually figures that one out, and so forth and so forth. So you kind of multiplying that kind of skill and so forth. Yeah, in order for that to happen, we need to have better interaction. So of course, we don't speak robotics. We don't have USB ports or similar interfaces. So we need to have ways by which we can actually kind of communicate between human and machines in a better and more effective way. Also, of course, what is very important is we need to kind of validate those processes. So increased, as you may kind of gather already from the topics I'm discussing, we're talking about kind of advanced sensors. We're talking about reasoning processes. There are, say, artificial intelligence. But what we mean with this is machine learning applications that kind of relate and look at patterns. Now, the challenge with this is, how do we formally validate that this processes, that the system as a whole will actually deliver what we think it will do, right? And that there are no kind of emerging properties that will result in some kind of unexpected behavior. So we need methods by which we can actually build those, this then formally validate or informally experimentally validate actually that the systems will actually perform the way we expect them to before we actually deploy them. Yeah, and other topics increase autonomy. So of course, this links to kind of productivity. So what we want is systems to support people in their kind of decision-making processes, enhance their capabilities to actually do more complex tasks, like dexterous handling and so forth. So if you want to manipulate a non-rigid object, for instance, that is often quite tricky using a kind of a traditional automation. So that's why in the automotive industry, we find that most of the automation, actually, counter to belief, is actually deployed and actually just manipulating rigid objects in the kind of body and white area. But most of the kind of installation work, so actually all the systems installation work, cable fitting, trims, and so forth, is actually done manually. So, about 400 robots in your kind of body shop, and then about 1,500 people actually putting all the installations into your car. Yeah, and finally, we want to actually look at enhanced resilience. So how do we actually adapt, to unexpected changes? I think the latest situation this year has been kind of giving us a little bit of kind of a fruitful thought in that area. But ultimately, what happens when things change? How do we make sure that actually we can actually adapt to that quite quickly, and we can kind of continue to survive and strive despite having automation systems, or maybe using those. Okay, so the topics we are covering, and that's kind of more or less the last slide, and the rest of the slide we can go through, as questions are being asked, is, what are the kind of innovation areas? So one of them is looking at adaptive, flexible automation that we see as being the kind of the core topic for us. So how do we get automation systems to be more versatile, easier to adapt and change over, which we see to be one of the key barriers why people actually find it hard to invest. That could be both technological as well as from a kind of financial perspective, so looking at business models around that. Then we have the kind of connectivity challenge, which I think most people in industry are kind of working around, to say, how do we connect devices up? How do we connect them in a way that actually allows them to share meaningful information, even to an extent, what is meaningful information in that space? So not just connecting everything just generates a lot of data. A lot of data will use a lot of space and makes it quite hard to analyze. So it's kind of figuring out what is actually relevant data. And then finally, actually, quite importantly in this context, what are the kind of social cultural implications of automation? What is the impact on the people that work with automation? How do they, kind of work, kind of in a trusting way, if you like? How do they make that kind of solutions work? And also, of course, what is the implication on the kind of labor security and things like that in that space? So there's a lot of things around that. There's a lot of training requirements. So how do we upskill people in the way that we can actually maximize the benefit of automation systems? What kinds of skills do they need, and how do we engage with that? And of course, finally, there's regulatory requirements. So anyone who's worked around safe robots will find that most of the setup at the moment around health and safety is based on case law. But of course, the issue with case law is that only exists once cases happened. And what we, of course, don't want to happen is those cases, right? So how do we actually build regulatory frameworks and build confidence around this kind of technology to allow them to work closely with people without actually having any accidents that will cause us to investigate what we should have done? So it's kind of getting involved early on. Okay, on that note, I think, well, let's have the benefits, right? So I'll leave that on the screen. So that's the kind of things we talked about. And finally is how do you get involved? And I think this is where we can take some questions and then, take it from there. So thank you very much for your attention. I hope it was, at least I didn't go and rush through it too quickly.
Thank you very much, Niels. Very, very interesting. Does anybody have any questions or comments they would like to make? I mean, by all means, use the chat functionality, or alternatively, give us a little wave to.
Good morning, Pim. It's Rob. And knowing that, Rob, as you know, I'm not the shy and retiring type, can I ask the first question?
Go for it, Rob.
Good morning, Niels. Fascinating presentation. And I've been involved in the motor industry my entire career, so I've seen a lot of development of robotics and automation into manufacturing facilities. Question for me is around the split between large organisations and SMEs. The SMMT says about £4 billion is invested annually into R&D in the industry. About 7% of that comes down to SMEs, where there is a lot of innovation, as our report that we've published with Bohurst recently shows. What for your program? What do you see the split, and do you see potential involvement and participation by SMEs?
Right. Okay. So we are very strongly encouraging SMEs to get involved, because we see that this is where the kind of the biggest challenges, if you like. So the larger companies also often have larger budgets, as you might expect, to kind of do the innovations that they want to do, whereas SMEs often struggle. And I think we're doing something wrong if we're not actually taking some of this kind of government funding and actually helping SMEs to kind of address their challenges. The other interesting point is actually that quite a few of the challenges that we found actually SMEs have in terms of kind of changeability, kind of small batch sizes, being agile and so forth, actually also quite similar to some of the things that happen in kind of the currently more manual processes in actually larger organizations that are kind of also their barriers. So we see that there's a potential kind of benefit for both to say, look, we have the kind of the larger volume customers, if you like, for automation that actually drive the market. But if we have kind of create automation that actually addresses also the challenges of SMEs, who don't actually necessarily individually have the budget that will tempt automation companies to develop the technology, we're kind of hitting both both birds with the same stone.
Thank you, Niels. That was very helpful. I'll be writing to you.
Okay.
And thanks, Rob. Were there any other questions from anybody? If so, please unmute yourself and let's have a go. I kind of have a question in terms of, I mean, is the focus of the project and what you're trying to achieve, is that all robotics led, or is there also a role or interest in sort of RPA, robotic process automation, so more sort of admin focused and data focused stuff?
What we're looking in this particular center, we're looking at more the kind of the physical implementations, or the kind of how do you make kind of process, or the kind of process automation side, so kind of manipulation, assembly type of challenges, kind of complex environments, changeability, and so forth. Of course, some of the things that we will be addressing in terms of autonomy and kind of creating algorithms, for instance, or testing algorithms to see how well they perform, actually not just once, but 1,000 times, 100,000 times without fault. Of course, are transferable also to some of the, let's say, more kind of service automation, if you like, or kind of office function automation side. But it's typically a different challenge, because in some ways the data that we're collecting is much more noisy. Because we work a lot with camera systems, for instance, and everyone who's used camera systems will know that they're quite sensitive to light conditions, to the types of component that you're dealing with, whether they're shiny or what surface finish they have, and that makes it quite hard to then actually develop reliable systems that actually work under kind of various conditions, to a point where factories basically just don't have windows, just to make sure that there is very little light pollution actually coming into those factories, which of course is not particularly pleasant for people typically. So there's a kind of some kind of trade-off to be had there.
Interesting. Actually, I mean, given the fact that today in England we're entering a second lockdown, do you actually anticipate that take-up might be bigger than you even anticipated, in terms of sort of programmers and maybe even operators being able to be based at home and work remotely and have sort of most of the physical activity done through robotic systems?
Well, it's certainly one of the trends we can see in other markets. So I had some numbers from just recently, actually, from the German kind of uptake of collaborative robotics. And I don't have the UK numbers yet, because I think BARA is only kind of working on them at the moment, which is the British Automation and Robotics Association. And it indicates that, as just in the case example, in Germany, the numbers of collaborative robots that were installed actually tripled actually this year alone. So there certainly seems to be a trend where people look at, well, if I'm working in a very dense environment, and I think again typical examples are people in food manufacturing situations, for instance, making sandwiches or things like that, are working very, very close proximity to each other in cramped conditions. So how do I actually kind of remove those types of kind of social situations, if you like, contact situations, which is not something we traditionally had to deal with. So that it certainly kind of puts some kind of incentive, let's say, into this area.
Excellent. Any other questions from anybody? Right. In terms of contribution from companies and things, have you got any more information on how that might work, and how you would select case studies and all that sort of stuff, maybe?
Yep, yeah, absolutely. I mean, so the way it typically works, I mean, particularly considering the current slightly challenging, economic conditions, is that we are looking for people to partner in terms of putting in their kind of time, so in-kind support. When we look at case studies, what we will have is there will be a kind of competitive process to kind of select case studies, and typically the case studies that, or feasibility studies that will be selected will be those where multiple end users kind of identify a need. There's support from multiple technology providers and system integrators to say, yes, actually we're quite interested in that, but also there is a kind of, let's say, a missing ingredient where we say, actually that thing we can't actually do easily, because if it can be done straight away, it's just a question of a commercial project, where people go like, I can solve this problem, I have a solution, talk to each other, find out what is the kind of the viable route, for you to do that, and under market conditions. And what we'd expect is, what we see as benefit is actually if people actually bringing in some of their engineers and second them to the project, for instance, and say, look, we're working together on this, put in some of your time, actually work on this, and actually you are learning it because you're learning the technology, you're seeing if the solution works, and you're working actually with our researchers and some of the research engineers from some, for instance, catapult centers and RTOs together on this problem, actually elevating, and fertilizing this kind of skill development within the company. Yeah, so that's how we see it. So it's all in kind contribution. Particularly, what we think as a kind of a viable business model is that roughly 1/3 of the kind of effort will be put in by the center, and then the remainder of that will come from end users, technology providers, and RTOs actually providing extra time into the projects.
And so, sort of not knowing what you don't know is kind of less of a barrier, because you would welcome companies coming to you to say, hey, would it be possible to do something along these lines? And then it's over to you guys to sort of investigate and see what might be possible. Is that right?
Yeah, I mean, it will be a combination of different things. So we have, kind of close links. Of course, we have kind of experience talking to people, and we kind of see what the kind of overall trends are. We have, access to the strategic roadmaps that have been developed by, various catapult centers and other centers, that have been engaging with many companies over, now about 10, 15 years or so. So they have a kind of a vast experience of where the challenges are. And what we then do is actually look at workshops and kind of sandpits to kind of bring people together and say, look, let's see where the critical mass activity, what are the really kind of breakthrough things that we should be working on. I'll have to say, though, that it's unlikely to be something where I say, this is one company specific, doing its, particular widget or something on this for that. It's more kind of saying, look, if we can do that kind of challenge, this kind of typical process, you can actually see that in a couple of years' time, if you had that would actually really transform your operation, because you could actually remove fences, or you could actually deploy automation into kind of processes that you can't currently do. Yeah. And also then use those to kind of showcase to the wider industry. So this will be also open to everyone. So we'll be looking to kind of create video material and things like that, where people then kind of look at it and kind of going like, oh, this is really interesting. I have a similar problem. I have a similar type of situation. How did they do that? Actually, who can I actually reach out to actually have a further conversation about these types of topics?
Yeah, excellent, fascinating. Right, does anybody have any other questions or comments before we wrap up? If you do, please unmute yourself and fire away. But if not, then I think we'll wrap it up here. So Niels, thank you very much for the presentation. Fascinating. I mean, as I mentioned in the chat, we will be sharing Niels and Carol's details with everybody. So if you did want to follow up individually, then you can do so afterwards. So really great stuff. As per usual, what I would like to do now is run a quick poll to get your views on this webinar and what you made of it, but also to give us some indication on what you would like us to look at next time for webinars and things. It should take less than a minute, so hopefully it won't be a problem for anybody to fill that in, so please have a go with that. While everybody does that, I'd like to thank our viewers on YouTube for watching. So thank you very much. Obviously, check out any of the other webinars that are on the channel. And as I said before, any future events, please come to our website at silverstoneTechnologyCluster.com and have a look there. And please do sign up for anything that takes your fancy. So thanks for watching and goodbye.